And in this lesson we'll review the power rule, trig derivatives, and vertical motion problems. So the power rule is just multiplying by the exponent and then subtracting 1 from the exponent, and we would have 12x cubed. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. Derivative of cotangent is negative cosecant squared. The derivative of secant is secant tangent. And here we have negative cosecant cotangent. We'll also look at vertical motion problems, and the position function for the height of the object is this. And the reason why these problems are included in this section is because we can find the velocity using the derivative. So h prime is the velocity. Multiply by 2, we get a 1. Subtract 1, and here we'll get rid of the variable by multiplying by 1 and 1 minus 1, so there's no more t there. The derivative of a constant is 0. We have to remember that the acceleration due to gravity on Earth is negative 32 feet per second squared, or negative 9.8 meters per second squared. If we use the power rule, we could write it like this. So negative 2 is the same as negative 2x to the 0. And then when we take the derivative, we can see why this derivative is going to be 0. Multiply by 0 and then subtract 1. But that's still a 0 there. So the power rule works. But we can also think of the graph. The graph of negative 2 is a horizontal line. The slope of the horizontal line is 0. So that's how we can also see the derivative of a constant is 0. And today, since the power rule is pretty simple, we'll just have to look at some functions that require rewriting before we use the power rule. So let's rewrite it like that. Multiply by negative 8, subtract 1, and now we have that. And if we wanted to find f prime of 1, we just put a 1 in there. Pause the video and try that one. We'll rewrite it. Multiply by the exponent 3 times negative 5. Negative 5 minus 1. F prime of 2. And when we have a radical, let's rewrite that with a fractional exponent. Now we can use the power rule. Multiply by the exponent. Subtract 1 from the exponent, but that's 4 over 4. So 1 over 4 minus 4 over 4 is negative 3 over 4. And let's change this to g prime of 16. The 4 is the root, 3 is the power. And we have a negative exponent, so we'll write it in the denominator with the 4. G prime of 16. And then we have a choice. We can do the root first or the power first. Let's do the root first because that will make the number smaller. 4th root of 16 is 2, and then we cube that and we get 8. 8 times 4 is 32. All right, pause the video and try that one. Rewrite it as a fractional exponent, multiply by the power, and subtract 1. This 1 is 3 over 3, so this will be negative 2 over 3. 1/3 minus 3/3. Third root of x squared. And then we can substitute an 8. And cubed root of 8 is 2. 2 squared is 4. 4 times 3 is 12. All right, so this would require the chain rule. We're not reviewing the chain rule yet, and that means we'll have to just expand that to 9x squared. And we can't use the power rule like this, so we're going to rewrite it as pi over 9 times x to the negative 2. And now we can use the power rule. Multiply by negative 2, subtract 1, pause the video and try that one. So here we don't have to square the 3, and we'll have 2/3 x to the negative 2, and we multiply by negative 2, subtract 1. So now we have a negative 4, 3 x to the 3rd. And we can deal with two different functions that are combined. Let's rewrite this to get so that we can use the power rule. And I think, go ahead and pause the video and try this one. Alright, so we can first write it as a fractional exponent. The cubed root is the 1/3 power. We can't use the power rule yet, so we have to rewrite it with a negative exponent. And now take the derivative and we'll multiply by negative 1/3, 2 times negative 1/3, and then we're going to subtract 1. That's subtracting 3 over 3, so now we have a negative 4 over 3. Here we have the derivative of cosine is negative sine. And we have negative 2/3. Let's put that in the denominator with a cubed root and the 4th power. 3 sine x. And pause the video and try this one. Rewrite it as a fractional exponent. And now do the power rule on this. The derivative of tangent is secant squared. And we'll have 1/5 x to the negative 4/5. So multiply by 1/5 and then subtract 1, or 5 over 5. So we get negative 4 over 5. Let's do the 5th root and x to the 4th in the denominator. Alright, so when we did these problems before, we want to look at all the different characteristics of the vertical motion and then find out which strategy we can use. The challenge to these problems in the beginning is that there are many different questions that can be asked. So we have to be flexible. And we have to choose which situation do we have. If this is time and this is the height, draw a picture of what's happening in this problem. It's thrown from 5 feet above the ground, so that'll be here. It's thrown upward from 5 feet above the ground, so it's starting here. This is if it's thrown from ground level, and this is if it's dropped. So we're going to use this one. And we want to fill in all the information that is given, and also information that we know, and we can find time, height, and velocity. Time, height, velocity for each of these. The time here is 0. The height was given as 5, and we know the velocity is 70. The time here we don't know. The height is what we're supposed to find, and the velocity we know is 0. They didn't tell us this, but we know at the maximum height the velocity is 0 because it goes up, it stops, and then comes down. This is what they're asking us to find, is the time that it's in the air. We know the height will be 0, and the velocity is a maximum, but we don't know what it is. We have the position function, and since the characteristics, the values are given in feet, let's make sure we have feet here. Negative 32 is A. Initial velocity is 70. Initial height is 5. And simplify that to be negative 16t squared plus 70t plus 5. And we can also, while we're at it, find the velocity, which is going to be negative 32t plus 70, the derivative of this. Okay, let's find the time in the air. Find the time when it, again, that could be the time that it hits the ground. So we have to say, for this time, we know height is 0, and we have an equation for height. So let's just find out when that equals 0, and that will be the time in the air. We can just use the quadratic formula. And we can see that the time in the air is 4.388 seconds. The other value is negative, and that would be in the graph where this would touch the t-axis. So we won't use that. Okay, and we didn't need to use any calculus for this. For the maximum height, we can use calculus, but we don't have to. To use calculus, we would want to find out when the velocity is 0. The maximum height has a velocity of 0, so we could use this and just set that equal to 0. The time of the maximum height is 70 over 32, and that means the maximum height is h of 70 over 32. So we need to put 70 over 32 into this, and that'll give us the maximum height. The maximum height is 81.563, and the other way to do it is with a vertex, and we'll go negative b over 2a. Then we can just find the vertex with that. So we'll stop there.